Okay, so here we're going to go through the first test. And so the first thing to notice on the first test is that we have multiple choice questions. And I want you to show all your work, and you'll get part marks if you don't get the correct answer. If you get the correct answer, you get full marks. And you can get part marks in two different ways. Part marks are awarded for crossing off the incorrect answers. You get 1 point per incorrect answer that you cross off, unless the correct answer is also crossed off. And you also get part marks for showing work in addition to that. So there's no penalty for crossing off a few incorrect answers. It's a way of making sure that you eliminate some answers that you know are physically not right, and it helps you to choose the right answer. So each multiple choice question is out of 5. And when we start out with a question, it's a good idea to first of all read it and then read it again. We're told that a baseball is hit at an initial velocity of 24 meters per second, 20 degrees above the horizontal. So we've got a diagram here that shows us that the angle is 20 degrees above the horizontal when we initially have this ball leaving the bat, as shown in figure 1. Neglecting air resistance, the smallest velocity of the ball before it hits the ground is. So here we're being told that there's no air resistance in this problem. This is a ball that's traveling in the air, so it will be in free fall. So this is a case of projectile motion. So we could write that down as a note to ourselves. And we're asked what the smallest velocity of the ball. So if we're thinking about velocity, we know it's a vector. And we want the smallest. For a vector, if it's a two-dimensional vector, the smallest is referring to the size of our velocity. So we need the smallest magnitude. So we're looking for a vector. That means that it is something that has components. So velocity is equal to our initial velocity in projectile motion is always going to be the same. So whatever our x component of our velocity is, we'll have an x component of the velocity and we'll have a y component of velocity. The y component of our velocity changes in time. And the magnitude of our velocity, our speed, is equal to the sum of the squares of the components of the velocity. Now, in projectile motion, we know that our motion in the y and x directions will look like a downward parabola. And at any point on that parabola, we have exactly the same horizontal component of the motion. But on the way up, we also have a vertical component of the motion. So here's Vx, Vy, Vx, and on the way down, we also have a vertical component of our motion. So we've got projectile motion gives us this parabola-like shape. We know that on the way up, we've got a positive velocity component in the y-axis and a negative velocity component in the y-axis on the way down. But in terms of the size of our velocity vector, our overall vector is going to be longest, if we do vector addition, at the very top. At the very, it's going to be smallest at the very top. So smallest velocity vector when at the top, when Vy is equal to 0. So now we want to look through our possible answers. Well, even before that, maybe we want to find our initial velocity. Our initial velocity in the x component is equal to our initial velocity times, if we break this into a triangle, this is the adjacent side, so this is Vi times the cosine of 20 degrees. So the x component is Vi times the cosine of 20 degrees. Put our calculator on here. 20 degrees cosine times the initial velocity's magnitude of 24 is 22.55 meters per second. So we're looking for something with a y component of 0 and an x component of 22.6 meters per second. This one doesn't work because it's got a y component that's non-zero. This one doesn't work because the whole time that this particle's in the air, it's actually got an x component of its velocity, so its velocity is never 0. And also that would be a speed. This is a speed as well. This, again, has a 0x component, so we're actually left with only one option that has a 0 component of the y component of the velocity. It would have been nice if this had units of meters per second, but 0 times any units is still going to be 0.